Okay, welcome math fans. Here we go. This is section 7.5 and I couldn't find anything good on con for this one, so we will just do this out of our book. This is page 481 is where we're starting, and at the bottom we will do the graphs for sketching the reciprocal function. Reciprocal, remember, just means the numerator and the denominator trade places. So if you had 2/3, the reciprocal would be 3/2. Okay, here we go. Our first one we are going to graph is y equals 1/x. You already know this function from our scrappy graphs. So you'll recall this is the hyperbola. So two branches and two asymptote lines. And we're going to see where that comes from. That actually comes from the reciprocal of a straight line, because if you take a straight line, which is y equals x, and take the reciprocal of x, the reciprocal is 1/x. So here's how that works. We're going to start with our equation of a straight line. We know that has a slope of 1 and a y-intercept of 0. So y-intercept of 0, and then 0, 0, 1 and 1, 2 and 4, etc. And we can draw a nice straight line. So do this on your graph paper and pause and get some graph paper if you haven't already. This will be way better on graph paper. Okay, then let's do the rules and you'll see how these work. So number 1, graph the y equals f at x. We did. Number 2, zeros become asymptotes. This is our 0, the x-intercept. Mark with a dotted line vertical and horizontal. So here we go. Vertical and horizontal. Number 3, mark the invariant points. Invariant, that is a word they absolutely love in grade 12 on the diploma. Invariant is not changing. So where y equals 1 and y equals -1, our y equals 1 is this line, horizontal, and you want where does that intersect with your other line, and y equals -1. So intersecting at the 1s, and sometimes I refer to that as marking your 1s. Then number 4, from the 1s, where the f at x bends away from the x-axis, the 1/f at x bends towards. So we are looking at from the 1 where it moves away from the x-axis. Now it will bend towards the x-axis. And then from that same one, where it moves towards the x-axis, it will bend away from the x-axis, and it'll get ever closer to the asymptote line but will never cross or touch. Same thing on the left-hand branch. So from that one where it moves towards, it will move away, and it'll move away on the same side, which is why I'm placing the sticky just to help us see that. And same thing on the left. So it moves away and now it will bend towards the x-axis. And we can see that we have our hyperbola that we expected. Number 5 says take the reciprocal of each y value. So this is not necessary because we've already finished our graph. But what happens is that is the actual rule of this whole thing. The steps above just make it quicker. So if we look and we had done take the reciprocal of each y value, well, reciprocal of 0 is the undefined, which is the asymptote line. Reciprocal of 1 is still 1. That's why it becomes invariant. Reciprocal of height of 2 is half. Reciprocal of 3 is 1/3. Reciprocal of 4 is 1/4, etc. And you can see if we went all the way to 100, way out there, that the reciprocal of 100 would be 1/100, which would barely be off of this line, and that is why we have a horizontal asymptote. Here, if we went over half, we would be up a half. Reciprocal of half is 2. And over 1/3 would be up a third. Reciprocal of 1/3 is 3, etc. That's where those actually come from. So this works super great. Okay, you pause the video, try this one, realizing this is your straight line moved to the left 5. And here we go. So I'm going to take this graph, my straight line moved left 5, or moved up 5. It's actually the exact same thing, depending on how you group those in your mind. And we'll graph that. And now we will do the rules. So zeros become asymptotes, and this time our 0 is at the -5. So vertical and horizontal asymptote lines. Mark our 1s. So height of 1 and a low of 1. This, starting at the dot, moves away, so it will bend towards the x-axis. This moves towards the x-axis, so it will bend away from the x-axis. Here, same idea. So moves towards the x-axis, and now it will bend away from the x-axis. Here, moves away, so it will bend towards the x-axis. And we are done. Notice that is the graph we expected, because we know this graph is our hyperbola, but it's moved left 5. So from our original moving left 5, yes, that's exactly what happened. They would like us to talk about the equation of the vertical asymptote. So equation of vertical asymptote and that will be our line here, the x equals 0. Notice that comes from the non-permissible values in the equation. They also like us to talk about the y-intercept. Well, the y-intercept in the original graph was 0, so the reciprocal of 0 is undefined. So we don't have a y-intercept at all there. This graph, the vertical asymptote, which I'm going to abbreviate with the VASY. So vertical asymptote is here at x equals -5, which you can see from the equation is the non-permissible value, and y-intercept. Y-intercept on our original graph was 5. Reciprocal of 5 is 1/5. And we can see that, yes, it looks like it should be perfectly at 1/5. Okay, number 3. Let's do this guy. I'm going to slide this page up just a little more. So, stop the video, graph your parabola to start with, and then continue. So my basic parabola is 0, 0, 1, and 1, 2, and 4. And a nice curve on both sides. And now my rules. Zeros become asymptotes. Mark with a dotted line. Vertical and horizontal. Then mark my invariant points, which are the 1s. So height of 1, I don't have any. That would correspond with the y equals -1. And now bending. So bends away from the 1, and now it's going to bend towards. Here it goes towards the x-axis, so it'll bend away. And that'll get ever closer to that asymptote line, but never touch or cross. Here, same idea. So bends towards the x-axis. So this one will bend away from the x-axis. Here, bends away, so it will bend towards the x-axis. And we have a nice little volcano. Equation of the vertical asymptote. So vertical asymptote in this case, x equals 0. And our y-intercept, none. All right, I have graphed the function, and now let's apply the rules. So number 1, graph the f at x, we did. Number 2, zeros become asymptotes, mark with a dotted line. Well, here they are. And they are at our plus and minus 3 this time. So mark with a dotted line, vertical and horizontal. And now let's bend. I can't really see that one. There we go. Oh, sorry. We need our 1s. So mark our 1s, height of 1, and this guy, height of 1. What is wrong with that? Oh no, okay. And low of 1. Okay, these are going to be tricky because they're tight next to that asymptote line. That's okay. So starting at our 1 moves away, which means it'll bend towards. This moves towards the x-axis and tightly stays on that side and moves away from the x-axis. This, same thing. This is nicer because I actually drew it more this way, even though it didn't quite hit there. So here moves away from the x-axis, which means it'll bend towards the x-axis, and this moves towards the x-axis, so now it will bend away from the x-axis. Same thing on the bottom. This moves towards, so it will bend away. This moves away until it gets to -9, so it will move towards the x-axis until it gets to -1/9, because we'll take the reciprocal. So that little point in there is going to be -1/9. Same thing on the other side. So this moves away until it gets to -9, which means it will move towards until it gets to -9. And that will, -1/9, and that will form a nice smooth curve there. This is tight towards the x-axis, and it will move away from the x-axis and sit inside there. So I hope you got that one. That's a tricky one. So vertical asymptote, try it if you didn't. Vertical asymptote is x equals plus and minus 3. And you can see this is the difference of squares. If you factored that, you would have y equals 1 over x plus 3 and x minus 3, which then would make it obvious that those plus and minus 3 would be your non-permissible values. And y-intercept, let's see. Y-intercept, Well, our original y-intercept was -1/9. Reciprocal is, or sorry, -9. Reciprocal is -1/9. Done for that one. Okay, last one I've already drawn, but start with your equation y equals x squared plus 2. You know that is a parabola moved up 2, and space out your graph further than you have on the others. That will make it easier. Then pause and try. Remember, if you can't do one of the rules, you just move on and try the next one. And if you can't do that one, move on, try the next one. Okay, here we go. So, number 1, graph the y equals f at x. We did that. Number 2, zeros become asymptotes. No zeros. Number 3, mark the invariant points where y equals plus and minus 1. No. Nothing at plus 1, nothing at y equals -1. Move on. From the ones, well, we don't have any ones, so we can't do anything. And we're down to number 5. Take the reciprocal of each y value. So here we go. Reciprocal of a height of 2 is half. Reciprocal of height of 3 is 1/3. Reciprocal of 6 is 1/6. And this will be the same on both sides. And you can see if I kept going way up to 100, then I would have a reciprocal of -100th. So it would be barely off this little x-axis line. So we're going to end up with a horizontal asymptote because of that idea. Then I'm going to draw a smooth curve, and I end up with a little hill, like a bunny hill when you're skiing, or like it used to be a great big hill and now Chinook has come and there it is, a small hill almost ready for spring. Vertical asymptote, if we look, we don't have a vertical asymptote at all, which makes sense because from our equation there's nothing we could put in for x that would make this denominator 0, so we wouldn't have any non-permissible values. Y-intercept is half because it used to be at 2 and the reciprocal is half. Aren't these so great? Okay, try some more. You're going to do questions 1 to 8, 10, and 13. On 6 and 7 it says use the calculator, but it is quicker not to. Hooray!